Greetings, fellow travelers. Welcome to an ENDESGA tutorial. Today, we'll be talking about lighting. Simple 2D lighting in GameMaker Studio. Now, bit of a disclaimer and precursor. If some of these features are not in GameMaker Studio 1, I do apologize. You will have things like GPU set blend mode. There are translated versions of those functions in GMS1, but this is kind of specifically for GMS2, but it will work regardless. So, without further ado, let's get straight into it. Now, I'm hoping my little preview here is not too weird, being kind of widescreen, and I'm hoping that you can see enough of the screen, and I'm hoping the text is going to be big enough for you to read. It's been a while since I've done a tutorial, but regardless, let's put on my headphones, get comfy here, as you should. Now, we're going to start off with a simple sort of scenario. A lighting engine or a lighting system is typically used for top-down, platformer, just sort of 2D games in general, as long as the thing you're looking at, the lighting... No, sorry. The scenario you're looking at doesn't have a sky. Now, the reason that is because a sky can be bright, or at least brighter than the land. Now, currently, it's a little more complicated to do lighting on just the objects and just the tiles, but have the light, like stars, for example, or maybe a moon, or something that is brighter, drawn behind the lighting with the lighting layer. You know what I mean. It's complicated. So we're doing things like, as I said, top-down, where you would just have the lighting covering everything. You're looking at the ground. Or, in Nykra's case, a room that has lighting, but it has no sky where the lighting can be kind of confused. Yeah, well, you'll see in a moment. Okay, so we're first going to start off by creating an object. Easily done if you're very familiar with GMS2, if you're a novice, if you've done this for a long time. Regardless, just make an object, just call it something like, I tend to call it something stupidly obvious, like lighting in all caps. That's just to make it so I don't lose it, or if I'm in the middle of the code and I want to find something related to it, I can easily just type in capital L-I-G-H-T. Easy. I do that for a lot in Nykra. A lot of like the control objects, I have very capital, obvious names. A lot of people put O at the front, and I would, if this was a less important object, I would go O, capital L, lowercase I-G-H-T-I-N-G. I would do that. But in this case, since it's a very obvious, very important object, as I said, I put full capitals. So, the next step is to just go into add event, go into draw, and you want to do something like draw end. Now, the reason why you want to do draw end instead of draw is because you can draw end can be manipulated in a few different ways. If the depth of the object is really low, in this case, if it's, let's say, 100, because the way the GameMaker works is if it's the negative, it's drawn above. If it's 100, it's drawn, or bigger the number, the further it is back, if that makes sense. So if it's something like 100, which would be it would be behind most objects anyway, and it's draw end, it means that any other object that has a draw end will be drawn on top of the lighting. This is important because it means that you can have the lighting layer, and then you can have UI over the front, like glowing UI, or just any sort of UI in general. It'll be drawn on above the lighting. It's important, and very important in Nykra as well. So that's the reason why we want to go draw end instead of draw, because if we just go draw, it means we have to have it either like negative 100 or negative 1000, depending on how broad your objects and tiles are, but you have to make sure it's above everything. But if you have draw end, you will know it will be above all of the draw events, because most objects and tiles and everything are on the draw event rather than draw end. Because what it does is it goes through all the objects, all of them. It goes through, I mean, there's more in between, but for the simplicity of this, it does draw begin for all of them, draw for all of them, and then draw end. So you can sort of imagine the layering within that as well. If you have this lighting, which is a depth of 100, and its draw end, it would be basically the first draw end to be drawn, but it would be after draw begin and draw. If that makes any sense whatsoever. Regardless, we're going to open up now. Hopefully that was a good enough explanation. I'm just going to adjust my windows here, since I like to make sure that everything I can see is in the space. I'm hoping my little box here isn't blocking some text. I'll also make this a bit bigger. Is that good? It is good. Beautiful. So in the draw end, we're simply just going to go, we're going to start off with a surface check. So we're going to go if surface exists, and we can name it anything we want. We can just go surf. I tend to call surfaces in the game just surf, because it's not going to be used by any other object. This is, as I said, a very easy to understand way of making a lighting system, rather than the most efficient way, which is probably using shaders and stuff like that. But this is using surfaces, very simple to understand. So, if surface exists, open curly, close curly, and we're going to go inside of it. So, the way we want to construct it is, we have a window, which is going to be the camera view sort of shape, but then we're going to draw. Well, there's actually two ways of doing this. You can either make it so the lighting is fixed to the camera, so it means that if you have a pixelated game, the pixels of the lighting will not match with the pixels of the game, because every time you move, it would sort of shift slightly. Again, this is hard to explain, but it's something that I found when making Nycra. I realize, since Nycra is really low res, it's like sixth of the resolution of standard HD, so it's like 320 by 180. It's really low res, so pixels are obvious. So when the lighting engine is drawn, sometimes the pixels would misalign because the position of the camera is different to the position of where everything is drawn in the world. Again, if that makes sense, good. If it doesn't, I could probably reiterate in the comments below. If you do have questions, I will try to answer them, but I'll also try my best to explain. So, one way to fix this is that you can simply use a round or floor. I found that round seems to work better. I don't know how. I would have thought floor would, because it's a 0-0 and everything's sort of floored in the layer. But round works. You basically get the position of the camera and you round it. And that will allow it to snap perfectly. Every time you move, it would allow it to snap perfectly to the actual pixels of the game itself. And it means that you can make individual pixels or individual things glow perfectly aligned with the sprites at which they come from. Now, before we start adding in the camera and adding in all the fancy color details and things like that, we're going to be adding the surface, making sure it works. And to do that, we're going to be adding an else in here. And we're going to be going surf is equal to surface create width and height. Now this is going to be kind of, it depends on what you're wanting, but in this case, as I said, we're going to be using cameras. So what we're wanting to do is we're going to go camera get view width, and we're going to go view camera 0. So that's the width. And the height of the camera is like that. Nice. So that's going to be the size of basically the view in which the game is going to be drawn. And that's perfectly fine. But since we're wanting to align the surface to the actual pixels of the game to make it look a little nicer, we're going to be adding a buffer, just sort of like a buffer border around it. So we're going to be adding 4. So we're going to go +4. On both of these, +4, and that's just 4 pixels on the width and height of it, which will give us a 2 pixel buffer to allow things, because sometimes basically what happens is if you have the exact size of the view or the camera as the surface, if it's rounding itself and it's moving, there will be bits around the bottom edges and top edges, depending on what you use, that will become revealed because it's aligning itself beyond the camera. You gotta have a buffer, because it's gotta draw beyond the screen, so it allows itself to not be clipped or not be showing what's actually underneath and to look nice. Again, you'll see in a moment. Now, in here, we're going to also be adding some of the variables of the view camera. Now, we haven't actually got the camera just yet, but we can still add in the variables. So we're going to go cx is equal to, that's camera x. I just use that because it's relatively easy. We're going to go round, and we're going to go cy is equal to round. I'm fairly messy when I set up variables. I tend to just do stuff like this. I sort of add the names and then fill in the details, so make sure I get them right. So in this case, it's camera get view x. It's view camera 0. And we can then close that bracket. So we make sure that's correct, which it is. And then we go here, we highlight, and we can actually bring this down. Since the font is a little bigger, I'm just going to do that. Just to make it a bit easier to read, and then we can go view Y. Now, what that will do is it will allow the surface itself to snap to the position of the real world rather than the camera position. But what we need to do is, since we've got that 4 pixel buffer, that's going to be 2 pixels on the left and right and 2 pixels on the top and bottom. So what we actually need to do here is we need to go -2. So we go -2. So what that will be is the top left hand corner of the screen, of the camera, -2 and then rounded. So that means that when we draw the whole entire surface, it will be the exact position, or at least the correct position, which it should be, because we're going +4 of the width and height. It should make sense in a while, but that's basically what you're going to do. If you want a bigger buffer, which you really don't need to, because rounding is in the space of 0.5, you can have more, but I just found that 2 is sort of that, you feel good about it. You don't need to make it any bigger. So now we need to make sure we have a camera. Now, if you already got a camera in your game, which you should do, because this tutorial is for something that you put on top of your game rather than at the start of the game itself, because lighting is an aesthetic. Never build a game with just aesthetics first, because it tends to not go the way you want. You need to plan it, and you need to build the core processes and things like camera, physics, collisions, everything. So we're just going to sort of cut some corners here, pretend as like we have a system already going. In this case, I'm going to go like O control, and then in here we're going to be going something like room start, or game start, or even just create. Just whatever works for you. It doesn't really matter. I'm just going to go room start because it's kind of easier to understand. And I'm going to just shift the window a little bit so I can see. Okay, so we're going to be setting up the camera. Fairly simple. We basically just have a temporary variable called cam. Doesn't really matter. Equals camera create. Then we're going to go camera set view size, not size. There we go. We're going to go camera and the width and height. Now this is the width and height of basically our surface that we're drawing to. Since this is going to be a really pixely game, in this example, technically this lighting system can be for any resolution, but this is for pixel lighting, since I know that a lot of people who came to me said they wanted lighting like Nicro, which I'm taking more literally and making it so it's a pixelated lighting system. So in this case, camera set view size cam, and the width and height are going to be the display width and height divided by a certain amount. So the way that I do it, I basically just go display get width divided by, I'm just going to SCL, which will be like scale, and I'm going to go comma, grab that, go like this, paste, I'm going to go height. Now SCL is going to be a variable that's going to be the scale of which our game is going to be. As I said, Nicro is divided by 6, and the way that I tend to calculate that is the size that's most important, that I feel when it comes to making sure things fit. You can have stuff that fit in the width, and it can be whatever size, but when the height changes is when a lot of the things like squares and boxes, because the height is generally the smallest one out of the two, right? You don't have a tall screen. They're always quite wide. So what you can do is you go display get height divided by a certain amount that you want the screen to basically be. In this case, this can get quite complicated when you're wanting a very specific scalars, and you can round it to a certain amount and blah blah blah. But instead, in this case, we're going to go divided by 180, that I know is 1080 divided by 6. Is that correct? It is indeed. Just making sure. Now what we can do is we can then go seal or floor. Now ceiling would make it bigger, right? Because if you're dividing it and it ends up with, so in this case, if we get the calculator here, when you go 1080 divided by 180, it's exactly 6. But there are screens out there that are 1200 divided by 180, and it's 6.66666. So that means if you seal it, it would turn to a 7. And that 7 means that when you're dividing the screen by 7, it would get smaller, right? Obviously. But if you want it to be basically as much screen as possible without things getting chopped off or things like that, I highly recommend flooring it. So in this case, it will be floor of that, which will be, if we get 1200 divided by 6, not 7, you get 200, right? As opposed to the divide by 7, which is this rather convoluted number in this case, but there are cases of which it is too small and it chops down far too much for it to work effectively. So floor is a good way to make sure that you're dividing it properly. Properly. So now we've got camera create, then we're setting the size of the camera, and then basically what we're going to do is we're going to go view camera of 0 is equal to cam. Now there are other things we can do. I'm not too sure if these are all necessarily needed. Surface, resize, ID, application surface. If you don't know what the application surface is, I highly recommend reading up on it. But basically what it is, the game is drawn to the application surface itself. So it means that whatever is going on in the game goes straight to the application surface, and depending on the size of that is how high res or low res or whatever it might be. In this case, I'm going to make it the size of the screen, or at least the resolution of the screen. Like this. Which will hopefully look good. Now, a lot of these variables, a lot of these tweaks and processes to make the camera and views work, a lot of rather fiddly. A lot of them require very specific numbers, depending if you want it to fill the screen or to not, or to be a certain size, and yada yada yada. It's kind of complicated, but for the most part, I'm just going to do my best to make sure this comes out looking well, and you can use the root and the process of creating this lighting system to help you produce your own. So this isn't necessarily a one-to-one copy what I'm doing, but more of this is how I do it and the process of it, and I recommend discovering and figuring it out to fit your game, because every game has a different lighting to it. Okay, so from there you will need to start building in your actual lighting functionality. In this case, we're just going to draw a simple glow from the center of the mouse, but before we do, we need to actually set up the surface to produce the black bit that we're going to be multiplying to the actual game itself, or the screen or camera or wherever you're drawing the lighting. And we're going to be using a multiply filter. So that means that 0, obviously, which is black, when multiplied to anything that's underneath, will turn to black. If it's white, which is 1, or 111 if you want to be RGB here, it will be completely transparent. So it means that anything that's 1 will be as if it's not there. So this is a good way to produce very convincing lighting. So it means you can have a very sort of soft glow that's from white to black, and it will look like it's actual, light coming from a source. So we're going to be first setting up the object of of this lighting control. So we're going to go surface set target surf, and we're going to go down here, we're going to go surface reset target. Very simple stuff. And in here we're going to go draw clear alpha, which is going to be color C black alpha 1. So it's going to completely cover the whole entire surface with black, and it will allow us to then put the lighting over the top. So in this case, we're going to go here. We're going to go GPU set blend mode, and as I said at the start of the video, if you're using GMS 1, this will probably be draw set blend mode, but GameMaker Studio 2, it's a little bit different. We've got GPU set blend mode. We're going to go BM add. So now we can do something like we're going to go draw circle color. We're going to go mouse X and mouse Y. A radius of something like 32, doesn't really matter, could be anything. C white, and color 2 will be something like C black. In fact, it will be C black because everything else is going to be black. And when you do add, adding 1 to black will make it 1. Adding black to black will not add anything because it's adding 0 to 0. Simple stuff. But if this is a game that you've already got and the camera's moving and the camera's in a different position, you will notice that if you have this, this will not work. Now this is because the mouse X and mouse Y positions are in relative to the actual room 0, 0 rather than the surface 0, 0. So this means that if your mouse is in 100, 100, but the camera is in a different position, let's say the camera is 50, 50, when you have the mouse X, mouse Y, it will go 100, 100 on the actual surface, and it will draw far too much down and right than you want it to. So what you need to do is, which is why we've got these things here, we need to go minus CX and minus CY. So that what that will do is that will minus the actual bit that the camera is already moved, which will allow us to have the perfect position of whatever we're drawing. So we're just, whenever you're drawing any sort of image, sprite, whatever, the X and Y position have to have the minus CX and minus CY. No matter where it is. I tend to have, let's say if it's got like some sort of animation or a highly complicated position, or if you want to move it slightly from the source, you put it in brackets, do whatever you want, minus whatever you want, and then you go minus CX. So now after we've done that, you can simply just start to add things, list things. A way that I do it is if we go if instance exists, for example, O light or O player or O it could be O enemy, just whatever it is. You just have to basically add this simple line. If it exists, let's say O light, we're gonna go like this, and then we're gonna go with O light, and then that's when you start to draw this sort of stuff. For example, you can go this, and you'd want to go basically X minus CX and Y minus CY, and this will actually pick up from outside of here because it's a temporary variable. It will allow itself to work correctly, it's all good, but basically that's what you want to do, and you can do whatever color you want. In this case, we're just going to go simple example here. We're just going to write col, and we're going to write, I'm just going to put in the object here just so we can have this example, and col will be make color. I'm going to go random 360 for the hue, saturation. Wait, hold on. Is hue 360 or 255? See, no matter how long you've been using GameMaker, there's always, I got 255. There's always something that will trip you up, and you're like, oh, wait, hold on, do I actually know that? So, what we're going to do, I'm going to quickly into our room, we're going to go and chuck in some of these lights. I'm just going to place a few. The view is actually quite small, so we'll actually not even see that many, but I'm just going to chuck a few like that. Mostly in this top left hand corner, because I said the view is going to actually be quite small. We're going to go back to the room editor. We're going to go down here and go viewports and cameras. In fact, it's been cut off. It's been cut off by the screen. But down at the bottom, here, I'll move my little picture here. Right, so right there, right here, we've got enable viewports, clear viewport background. Yep. Visible. Yep. That's all good, and we'll change that. That's going to be changed in the code as well, so don't worry about changing this in the actual room. It's all good. So that's all good. Let's move my little back. And now we're going to just start to debug, and I know for sure that we haven't even started drawing it in, but after that we can actually start to test it. Okay, so what you're wanting to do, and this is very, very important, is you're wanting to have another blend mode, but this one is going to be an EXT. So GPU set blend mode, EXT. Then we've got source and destination. So we're going to go blend mode 0, blend mode subtract. This is basically a multiply blend mode that you'd find in like Photoshop or any other image processing tool. And what it was is, as I said, it gets the RGB value of whatever color and multiplies it to the color that's underneath it. So if it's 1, it will be basically transparent or invisible, and if it's 0, it will become black. So from there, we can easily just go draw surface like this, and we can go surf. And now we need the X and Y position. The X and Y position is quite simply CX and CY, as if we had before. As I said, it's the position of the camera positions. Very simple to understand, should be easy to implement, and you need to also remember to chuck in a normal here to reset the blend mode. And that's basically it. That's kind of all we need. And now what we're going to do is put in a background, maybe a checkerboard background, so we can see what the actual effect is. And yeah, let's do that. Right, so we've got a checkerboard tile. We chucked it into the room by just going to background, selecting the sprite, going vertical tile, horizontal tile. Easy, easy. Lemon squeezy. And we're going to just simply chuck in the lighting, like, if we choose the right layer, it's always fun, isn't it? So I'm going to go lighting, and we're also going to chuck in the control there to give us the adequate view camera. So now we can run and test. And there's a good chance that we're going to have numerous problems, but we're going to fix most of them, hopefully, and we'll see how this goes. Okay, so we've got our first bug. Pretty obvious. This one, we haven't actually set up the surf variable, so we're going to go surf is equal to -1. That is just so we can, so we don't have to type in the actual surface code here for the correct width and height. We'll just go -1, which will register it as not existing, and then we'll just create it. So let's try it again. Okay, so as you can see, we've got the lighting. It's not exactly the way that we're wanting. Things are a little odd. You can see that the actual camera view scale is not exactly what we're wanting as well. But for the most part, it is working, and it's working quite well. As I said, I'll have to adjust some of the camera scales to make sure that it's actually going to be drawing at a pixel level. So let's do that. Let's fix that. Okay, so a few things you need to do that will actually make it look a little bit better to fit the size is you need to set the window. So you go window, set size, display get width. In this case, I'm doing divided by 2 because I want it to fit in the actual, video. But you can actually just go nothing, and that will be the size of your screen. And what that will do, along with if you go to options, windows, and you go borderless window, what that will do is it'll allow you to have full screen without going into full screen. So it allows you to still interact with windows without going into full screen. Now, if you want obviously, if you want to go completely into full screen, you can just simply go, just type in full screen, and you go Windows set full screen, and then you go 1, like that, somewhere in here, and that will make it full screen. But for this tutorial, I'm not going to make it full screen, but in here, this window set size, that's the size of the window of the game that the game will try to draw to. We've also got display set GUI size, which allow us to interact with the GUI surface to give us a higher res surface to allow us to draw things like text or something that's going to be super high res compared to the pixel game itself. Now, as I said, we've also got surface resize of the application surface. Got display get width, display get height, and that's going to be it. So we've got a pixely game that's going to be drawn to a higher res surface, which will allow things to look smooth. So if you have an object that moves in not whole numbers like decimals, if you use my collision system, it will be really smooth and really nice to watch. So this is basically what Niagara uses. It's fairly simple. We've also added the width port and height port, which is just the width and height. And that's basically it. So if we go run here, now as I said, it's 180, so this will be exactly 180 pixels tall. Now the window is positioned all the way to the right over there because I haven't actually moved the position of the actual window itself to the center of the screen. But you can see it works. Like, we've got the lighting, and it looks great. Like, it's looking real promising. And that's basically it, really, for the lighting, because then you can start to draw sprites. You can start to draw anything, really, that you want using this lighting system. Super simple, super easy to understand. As I said, you can have any sort of shape, any sort of light, any sort of movement or motion. And that's basically as far as it goes. Because then once you have the moving camera, it will essentially align to it and it'll be pixelated. But it will mean that when you're still, or when there's lighting or objects moving and have specific glowing parts, whatever you want, they will align perfectly to the object themselves. So if their position is rounded as well. So if you have like the player, for example, and the player has glowing eyes or something, and the player is moving in decimal positions, the eye will not align to the player. But it's mainly for environmental things like with tiles or for objects that are stationary and not dynamic. But for the most part, as I said, that's basically it. That is how I do the lighting system in Niagara. That is how I do lighting in Borrowed Time, another game that I've made. Super simple, honestly super simple, and I highly recommend going over what I said, making sure you understand, because a lot of these things can be a little confusing. But to summarize, we've got checking if the surface exists. We create the CX and CY position, which is the rounded position minus the buffer. We then set the target, clear the alpha completely, set the blend mode to add, so when we add two colors together, it glows, becomes brighter. We can then draw whatever we want on the surface. In this case, I've got a circle glow that centers to the mouse, and we've also got a light that happens to follow any sort of light that's in the room. And basically you just have a whole list of every single object that might glow, and that's why when you have this if instance exists, if it doesn't exist, it won't draw it. So in Niagara, for example, I've got like 600 lines of code where it's just many bits of those, and though it's probably not the most efficient way of doing it, it's easy to understand because you can easily just add things, put things in without having to go into each individual object, into their own thing, which all like sort of cast their drawing events to the lighting itself, which what I used to do. But this is super easy to understand in my opinion, and I hope it helps. We then reset the target, we then set the blend mode to multiply. As I said, so 0, 0, if it's any dark sort of colors, it will get darker. If it's white, it will just be completely transparent. And you can do blues, you can do reds, you can do anything, and it looks great. You draw the surface using CX and CY, and then you set the blend mode to normal, as it was, and if the surface doesn't exist, it just creates it using the +4 buffer. And that's it. That's honestly it. So there we go. That's a super simple lighting system. I hope you enjoyed. I'd like to thank everyone on my Patreon for helping out. If you'd like to become Patreon, links down below and links in the video as well. And thank you very much. and I shall see you all next time. Hopefully, I'll be able to make another tutorial, since I know that a lot of people request these sort of things, and I just have to find time outside of making my game. But thank you all for watching, and I'll see you all. Jana.